All right, this is statistical studies and sampling methods. So we're going to be learning how to take samples and stuff like that. The biggest definition in here is actually the definition of bias. Like, what is bias? Yeah, make that bigger where you can see it. Bias is a prejudice, inclination, or tendency for or against something, a person or a group or something, typically in a way considered unfair. That's what bias is. Something that's considered unfair. And it might be on purpose, and it might just happen. Bias is just something you introduce into an experiment that shouldn't be there. And it might be because of how you set up the experiment, but it leads the experiment to go the wrong direction, not towards what you thought was going to happen. And we try to eliminate bias. Let's see here. Jacinta and Felix were each asked to design a study to answer the question, what proportion of students at this school listen to music while studying? So Jacinta, she talked to her friends in gym class. And you can see that roughly, looks like, how many are there total here? I can barely count. So 3 out of 7 listen to music while studying, and 4 do not. So 3 in 7 listen to music. Now, she only talked to kids in her gym class, and the key word here is they were her friends, so they were a lot like her. That's another part of the bias. Felix went to students in the library, and the question was, do you listen to music? So students listening to music in the library, most of them were not. About 5, 10, 15, 20, 25, 30, 35, 43. So he only counted 43 of 100 students that were listening to music while studying. Now, both of these kids have issues. So his was 43 and 100. What group did Jacinta select from to conduct her study? What group did Felix? Obviously, Jacinta was in her gym class. How did Jacinta choose which members of her group to question? How did Felix? Now, Jacinta was lazy. That's a big part of it. She was lazy, okay? This usually introduces bias. She only surveyed her friends in gym class. Now, Felix was not as lazy. Felix went to the library. So he got a pretty diverse group and more people too, and more people. I can barely think. You'll just have to forgive me. The food poisoning's really got me messed up. Does Felix's have some bias? Possibly. Does it have as much as Jacinta? No. But Felix's study has less bias by design. He had more people in a sample. It was a more diverse group. And the main thing is he wasn't lazy. He was not lazy. He actually went and did something. Jacinta's just lazy. Plain and simple. I would trust Felix's studies over Jacinta's any day of the week. I would. All right. How can you choose the best type of study to answer given statistical questions? Which of the 3 main types of study is shown in the example below? We have what's called a sample survey, an experiment, and an observational study. And I haven't defined these in the notes yet, so now's a good point. Plus, it's already given in here. A newspaper polls randomly selected residents in a town about which mayoral candidate they prefer. This is a sample survey. It asks every member of a sample the same set of questions and records the answer. It does have bias in the fact that only the people that respond are going to be in there. A doctor conducts a clinical trial of a new blood pressure medicine by prescribing it to half his patients in the study and measuring the effect that it has on their blood pressure. That's an experiment because we have a control group. We have the group that was not treated with the blood pressure medicine, and we have the group that was. So, an experiment involves applying a treatment to some group or groups and measuring the effects of the treatment. A grocery store wonders how many customers bring reusable grocery bags to the store. They have an employee stand at the checkout and count the number of people using reusable bags. This is an observation because all that person did was observe and count. You measure, but you do not affect anything. Nobody knew what that person was doing. That's an observational study. Those are our three big types of studies: sample surveys, experiments, and observational studies. What type of study could you use to answer the following questions? Does urban pollution have an effect on rates of asthma? Some people would say this would be an experiment, but then you would have to literally expose people to pollution. This is an observational study. You observe residents of urban and non-urban areas and compare the rates of asthma over a long period of time. If you believe pollution is contributing to asthma, that's how you do it. Don't introduce people to poisonous stuff. How many students in a school would like the cafeteria to serve breakfast? Probably a survey. That would be my guess. Sample survey. You asked randomly chosen students in the school and record their opinion. A group of plants is not growing well compared to the rest. What should you change to improve their growth? This sounds like an experiment because we're going to be adding variables in and recording the differences. So we are influencing it. That is an experiment. So you split the plants into groups randomly, give each group different conditions such as more light, more water, different fertilizer, and you leave a control group, a group where nothing has changed. All right, what type of study is described? A gym asks its customers if they would prefer the gym to open earlier in the morning. That would be done by doing a sample survey. You just ask people questions. That's a survey. A gym tries out a new weightlifting method to see if it will build muscle for their customers faster than their current method. Probably an experiment. What you would do is you would assign half the new regiment, and you would leave the other half alone. They would just keep doing the same thing they've been doing. One of the big things about experiments is you usually assign your groups randomly. A gym counts the number of customers who come in before 8 a.m. Now, that seems like that was done earlier with the grocery store, right? That's an observational study. You're not really doing anything, you're just counting. And the reason you might want to know that is you might want to know how many people you keep on staff before 8 a.m. Plain and simple. How many people need to be there? All right. Oh, here's bias again. A better definition of bias. A study has bias if it systematically produces results that misrepresent a population. Bias might also arise if a sample is more likely to include a certain category of the population than another. For example, a poll on a website is more likely to select frequent internet users than those who do not go online. So it might reject a large percentage of our older population, the pre-internet people. All right. Determine sources of bias. In the following situations, are the differences between groups potentially due to bias? So a psychologist is conducting surveys to study the happiness of people who live in a neighborhood. She asked the same questions, the two samples below, chosen from the population of the neighborhood. So both of these pictures represent people who live in a neighborhood. Here we have some people outside playing with their kid. Be right there. There are 100 people surveyed on a sunny Saturday afternoon, and everybody, 65% were happy, versus 100 people surveyed Monday morning, and only 35% of people are happy. Is there bias? Yes. I'll be there in a minute. It's biased. Of course, people are happy on the weekend. I better go get to that door before they beat it down. All right, so we were talking about bias, right? But yeah, that makes more sense. I mean, look at these poor, miserable people on their way to work on a Monday morning. Nobody's happy on a Monday morning. All right. In the following situations, are the differences between groups potentially due to bias? A school wants to know the average height of its students. The school randomly chooses some students and measures their height. Some students are under 5 feet tall and some are over 6'5" tall. Uh, Probably not. What I like is that they did random selection. And unless that's done really bad, the odds of there being bias are slim to none, but likely not. There's likely no bias. Now, it all depends. Like, did they just randomly pick freshmen? But I would say likely no bias, and that's due to the random choice. So, and we have a pretty good distribution of heights, right? We got some at 5, some over 6'5". It seems legit. Of course, I know we have some kids under 5 feet tall in this school. With Arden gone, I don't know if anybody's over 6'5" right now. All right, try it. A soft drink company calls 500 people at random and asks, is our product or our rival's product the best soft drink on the market? Why is this question a potential source of bias? Because they only gave you two choices. That's the problem with the question. This is a loaded question with only two choices. That's it. If the question is which is better, Pepsi or Coke, well, the results of that study could say that 80% of all people prefer Pepsi. This isn't true. Like, what about Fanta, which is actually how you pronounce it? You don't pronounce it the way the McDonald's people tell you how to. What about Fanta? Lots of people like Fanta. Uh, what about Sprite? Mountain Dew. Mountain Dew's probably a winner. Dr. Pepper. What about those guys? So, yes, it is biased because it only gives you two choices. That's the bias. It's this or that, not all the other options. All right, next up is sampling methods. So, when you sample, there's several common ways to do samples, and a couple of them have a high risk of bias. They all have risk of bias, but some of them more than others. So, here's our different types of sampling. We have stratified sampling, we have cluster sampling, systematic sampling, and these are the ones where you take care to reduce bias. These two, no matter what you do, they probably are biased. Convenient sampling and self-selected sampling. And they are two of the worst when it comes to bias. Let's talk about the worst ones. Self-selected is when you decide to give somebody your opinion on something. That's the bias. Because you're only going to be for or against, and you're going to be passionate about it. Convenience sampling is choosing people that are close to you. You're being lazy. Think about laziness with convenience. They're usually what I call lazy. Systematic sampling is a pretty common one. You start with one member chosen at random, and then you systematically pick like every third or every fifth person that you see. That's the system. There's a system to it. Cluster and stratified students often get mixed up. Cluster sampling, and I'm reading verbatim the definition here, is when a population is divided into convenient clusters and entire clusters are chosen at random as the sample. So you can kind of see here in the diagram, they divided these 18 people into three groups of 6, and then they picked on 6 of them. Okay? That's clustering. You divide and then take the whole. Stratified is when a population is divided into groups that have similar characteristics, but then we randomly sample from each group. So we had a population here of 12. They were split into two groups because these two groups are similar. Maybe it was boys and girls, but then we randomly picked 3 from each group. That's stratification. All right, what sampling method is used in the following examples? Is the method likely to be biased? Starting with a randomly chosen ID number every fifth. That every fifth right there, that is going to be systematic. I guarantee you the box over here says systematic. It is systematic sampling. Every fifth was picked. A retailer put feedback cards at the front of its store. They got responses from 22% of their customers. So if there's a survey box at the front of the store, you are deciding to fill out that survey. That is self-selected, high risk of bias. A city wants to know what percent of people in the city own a dog or a cat. A city worker goes door to door in the neighborhood around City Hall. So they're being lazy. That's called convenient. There's going to be a convenient problem. It's convenient sampling. All right. More identifying a sample. What sampling method is used in the following examples? Is the method likely to be biased or not? Population is grouped according to age, and a random sample is chosen from each group. This is going to be stratified. We have divided population into similar groups, the grouping being ages, and randomly selected from each group. Is this stratified? All right. Likely no bias. Number of hospitals around the country were randomly chosen. Within each hospital, all of the nurses were chosen. This is clustering. Because we have divided them into convenient groups. And then we have chosen a specific cluster within that group. That is clustering. A cluster of nurses was chosen. That is a cluster. All right, describe a design for a controlled experiment. Test a new drug for treating the flu on mice. How does randomization apply to your design? There needs to be two groups. So we have two groups. We have a control group. The mice are given no drugs. Then we have the experimental group. Mice are given the flu drug. Now, you would not test a human drug on a mouse. We're not close enough for that to make any sense. So I don't know why they're doing that, but apparently we want to cure the mice of flu. Makes no sense. We probably spend billions of dollars on that. Who gives a rat's rear end if a mouse gets a flu or not? Like, who cares? Seriously, it's a mouse. Anyways, that has not. Maybe you're pro mouse. I don't know. Anyways, well, the big deal is randomization. And all you got to do is make a little disclaimer here. Mice are randomly chosen to be in the experimental group. It could be systematic, something like that. You could take every third mouse or whatever, or maybe do a systematic approach. Every third is taken. But I would definitely probably do the randomly chosen. All right. And I think that's it in your notes. That's all the notes I'm doing. That is going to be 11.2, sampling techniques.